We've talked a lot about the voice of the customer in our systems engineering activities so far in class, but let's talk now about architecture as it relates to the voice of design moving forward. Okay, so here we want to basically explore a number of different factors that we should work into our designs, the X's, if you will, the inputs, the capabilities we want our system to have. And I refer to architecture as the voice of design because architecture really is about how to build a good system. Voice of the customer was about making sure we build the right system, getting our stakeholder requirements, and working that through a functional model so that the system we build will actually solve the problems of the customer. But for any given set of customer requirements, there are an almost infinite range of possible systems that we could actually build to meet those requirements. And there's nothing about this customer requirements that can really tell us what the good and bad architectures are for our system. It's really the range of architecture that allows us to discuss what a good system looks like. So where stakeholder requirements were about building the right system, architecture is going to be about building a good system as we go forward. So in system engineering, we use quality function deployment to maintain an integration and a traceability among several levels of requirements as we go through, starting with customer requirements on the far left, working ourselves through process requirements to functional requirements to design system requirements and ultimately to operational requirements. We work through those levels to make sure we can build the right system to satisfy our customers as we go through. So we're going to use the exact same tools. We're not changing our tool set, but we're changing our perspective on who we think the customer of this process really is. Because we as systems engineers are going to need to put a system in place that can both be operated, maintained, enhanced, expanded, and it's not our users and stakeholders who are going to do that. It's really people on the systemic side. So we have a whole range of new stakeholders that are going to think of our system as either good or bad system design, regardless of what it does for the customers going through. So we really want to add some features and requirements to our QFD model, the architectural characteristics that we're interested in, and we refer to that as the voice of design. Sometimes we see it as design for X, because we're looking for a variety of X factors that we build into our systems over time. So one of the ways we go about doing this is architectural analysis. We look at some high priority architectural scenarios, those situations where we're really going to put our system to the test in operations. We make sure the architecture that we design is going to be able to handle that as we go through. So we prioritize various situations, but the types of things we're looking for are use cases in the user design that show us the normal and future expected situations the system will be used in, maybe some desirable future situations in terms of business growth. Or extreme future situations that aren't necessarily desirable, we want to make sure they're going to work. So if the business is looking to double its volume in the next year, don't design your system for the current volume, design it for that future volume. So the areas we're concerned with here are the normal and stressful operations of the system. Organizational authorization levels, could that change over time? Some critical functionalities and their timings, some of the logistical and operational variances that we might not want to see increase over time, and some of the legacy system impacts for the systems around our system that we want to deal with. So those are things we will look at when we're dealing with architecture. We also take several approaches to architecture as we go through in terms of the tools and the constructs that we bring to bear as we're working on different architectural scenarios. So for instance, we might look at trees principles, the separation of space and time as an example, to map that to our architectural approaches to come up with design options that work. So there's several things going on there that we're going to be able to do as we go through. Likewise, we then look at a collection of factors that are pretty well known and well defined as constituting architectural design. They're not the only factors we're going to deal with. There are several factors that are considered the standard ones that we look at when we're doing architectural design of any given system. So these are the things we build into our system that we look at if we're doing Kano analysis of dissatisfiers for our customer or critical to quality analysis for our customer requirements. We're going to look at those things and really say what could get in the way of meeting those critical to quality characteristics, or what might we design into our system that would result in dissatisfiers showing up for our customers. So we start talking about this very early in the life cycle. We work on it throughout the life cycle. Architectural design is not something you do after you know the customer requirements. It's something you do throughout the system engineering life cycle to make sure you're always thinking in terms of what architectural options will best meet the needs of these stakeholder requirements that we're defining as we go through this basic requirement. So here's a list of commonly noted X's, architectural factors: correctness, reliability, efficiency. They're things you tend to want to do a good job of doing, but because of project constraints, that desire to deliver a fast, quality system at low cost that meets the customer's needs, these are tough factors because they drive the quality of the system, but they don't help us usually establish a lot of extra functionality for our customers, and they often cost more money to implement than if in the short term than if we don't. In the long term, if we don't do these things, the system can be a disaster. But in the short term, it's very difficult to take the time necessary to design in these components. So typically I use a worksheet like this, perhaps on a project, to prioritize and say, of all the different X's I could be looking at architecturally, which ones will really drive my process as I go. So I might work with my stakeholders to identify the top 5 architectural factors that I'm really going to pay a lot of attention to. On a very high risk project, I might look for the top 10 factors I'm going to look at. So I'm not going to turn this into an exercise of exhaustively developing the perfect architecture. But clearly, as you go through your career as a system engineer, you will develop heuristics and tricks you use in each of these areas that hopefully will make it easier and easier over time for you to implement a good, sound system architecture without a lot of extra burden on top of the projects that you're architecting. So out of that architectural analysis, we get a number of things that we would call the kind of our architectural design. We get sensitivity points. Where in the system are we sensitive to architectural change, where it appears it will make a difference based on those decisions. Where our tolerance is so tight that we've got to be a little careful. The trade-off points, so where are the trade-offs that we're going to have to potentially make as we go through, and what are our architectural risks? So those are 3 things you end up looking at. It's never done. You're constantly looking at these things as you go through the engineering process. You're just doing it with an eye toward building a good system. We all know good systems and bad systems, regardless of what they do, regardless of what the stakeholder requirements are, regardless of what the mission of the system is. We all know a good system when we see one and a bad system when we see one. The difference is architecture. That's what we're talking about here as we go through. So when we're looking at those architectural factors, whatever we've prioritized, we want to make sure we understand how they relate to the voice of the customer that we're already working on in terms of the customer side of our stakeholders. So if we look at the voice of the customer and look at theirs, there are certain architectural factors that have a correlation or a relationship with certain factors on the customer side. So if critical functionality would be part of how you would describe the stakeholders' needs on the voice of the customer, then you're probably going to look at reliability and correctness and testability as 3 of the architectural features you're looking for. If your system is going to have a lot of novice users or operators who have never seen this kind of system before, then usability and integrity are going to be important. So again, the factors relate to customer requirements, and so you can't do this in complete isolation. The priority of the architectural X's is going to be driven by the requirements of the customer and which architectural features are going to be more important. So once you identify which factors are important, your QFD can keep taking that to lower and lower levels as you go through. So you might take the high-level attributes that you've chosen, like correctness, say, well, how are we going to drive correctness into our system? Let's emphasize traceability and consistency and completeness. And that's how you might build your verification and validation plan around your system, your design reviews into your system to make sure you're getting those kinds of characteristics out. If you decided that flexibility is an important capability of your system, then you're going to review your system for modularity and expandability and generality. So you're going to keep drilling it down, just like on the stakeholder requirement side. You're going to keep drilling it down, saying, what should I be looking for architecturally to make sure that I'm meeting the high order architectural X's, the architectural requirements, such that they support the stakeholder requirements and mission of the system that I'm trying to design. So design for X, or voice of design, allows you to identify those things that are particularly relevant to the system that you're working on and make sure you've included them in your architectural factors for your engineering design. Don't expect your stakeholders to come in and say, I want you to have a system with a high reliability, or I want you to have a system with good traceability. Your users, operators, stakeholders, your business sponsors, they're looking at themselves as the voice of the customer. You as a system engineer and your peers, your team, you need to bring voice of design into this construct. So if you're taking systems engineering in a class like this, you're learning mostly the voice of the customer, how to get those requirements out. Later you'll take a systems architecture class where the emphasis will be on the voice of design on top of that system. The two go hand in hand. They're never really separate. You're always doing both. But sometimes because they're typically taught in two different classes, you can get the impression that they're separate disciplines. But really the systems engineering process is an intertwined braid of modeling and understanding and working with both the voice of the customer and the voice of design to produce a system of extremely high quality.